Now this is the immersion glass cube in which there is a diamond inside and there is no windows given, but you can straight away see from this immersion glass everything inside without giving any windows. This is Ambox 2.0, which is a 6-axis completely motorized microscopic machine. So to start, it is very easy. Just right click and press enter. The microscope will automatically initialize itself. So all the axes which are z-axis, so it will go up, it will go down, it will initialize automatically. There are 6 axes, so this is one of the axes which is we call as ry axis, so it will rotate. Then Rx, that is on the center, so Rx will also initialize. There are 6 axes in total, so all the 6 axes will be initialized and it will go to their home position. This is all everything automatic, but you have to wait for some time, and once X, Y, Z, Rx, Ry and Z zoom, everything is initialized, so the screen will come. So now as you can see, this is the immersion glass cube which has been stick inside, the diamond is inside the immersion glass, and this is a stage. So now we go on a desktop, we find out the file in which this model was created earlier, so we call it RecoLM, we open that project. So this is a laser map model which was earlier done in Helium Rough. So there is an immersion tab here. Then just load immersion cube. This is the same cube which we had made earlier in the Helium Rough machine. So we had just saved earlier as cube.mmd. We just opened the same cube. So now we have 2 models, the rough model and the cube model. So now just we press live camera. So now if you want to see everything inside the diamond, so this is the immersion light. So now we put the immersion light inside at the place. We also put a filter. So this is the filter. So light is completely sprayed out evenly. This is an immersion light setup which we have to place. So this is a 3D mouse. We call it a 3D gaming mouse. And there's a knob inside. So as you can see, you can rotate it clockwise, anti-clockwise. You can shift it left, right, up, down, everything. So it's a kind of a game. So as you can see, I'm moving it left and right. I can move it in front or in back. Now I zoom down to 7.8x. That is the minimum zoom of Ambox. Now after putting it, so we are now once again putting the same notch and we are trying to put the stone in the same stage. As soon as the stone is placed, if at all any movement is done by the hand which is not known to the computer, it will try to tell you that movement has been done manually, so should I initialize it, and just yes, say okay. So everything is automatic, you don't have to worry, he will automatically rotate itself, it will initialize, and it will make sure your model is exactly aligned as per the system. So as you can see, it is completely aligned, so you don't have to worry even if you by hand you have touched the things. So now once again I am demonstrating the 3D mouse movement. As you can see, I can rotate all the motors, 6 motors in any directions. So left, right, up, down, Rx, Ry. So there are in total 6 motors. So now in the program, we are going to plot only 3 types of inclusions. One big inclusion, one crack, there could be 2 types of crack, one flat crack and one curve crack, which is a curvature crack. Sometimes the people also see them as glitz. So these 3 types, and 4th one will be the pinpoint, which are known as IF or internally flawless or less than a 5 microns. small pinpoints. So now let's concentrate on the first thing. So we zoom the microscope by 50x, digitally zoom by 500 times. So we press IGQ, go on a surface. So as soon as it is placed, it will be automatically, the surface is automatically detected by the client. So if there is a dust on the surface, so what we are trying to do over here is that if there is a model discrepancy between these two, then we just correct the surface of this. So we once again go to 160x and just wanted to confirm that if the surface which is shown by the model and the diamond is the same, then if we just adjust and say there could be an error of say 10-20 microns. So it is, the correction is applied, 14 microns correction is done. So now once again, now we correct or come on the rough and we place on the surface. So once again we are zooming it down, zooming it up. Just wanted to ascertain that whatever model and the diamond are correctly aligned, the surface is correct or not. Normally it should be there, but there could be an error of 10-15 microns, sometimes 5 microns, or there could not be any error. Just you need to confirm that it is focused on the surface or not. Now, let us plot this big inclusion. So you can even change the step of whenever you move the mouse, you can change the steps, 10 microns, 50 microns, 5 microns. So inside you can zoom it, you can zoom down. So these are the small inclusion which are known as point inclusion. We will call it a point inclusion. So distance to rough, as you have seen, it is 1600 microns. So we go for 160x. Now we are going inside, right? Now this is a small inclusion and we are concerned about. Let us plot this inclusion first. So as you can click on cross and pair. Suppose if you want to have a higher kind of contrast, there are a lot of adjustments which you can do, which we call as a tone mapping. That is known as live exposure tone mapping system, which is so unique that you can see any faintest of the inclusion with a high contrast. This is as such not needed, but you can definitely play around for looking of some inclusion which are so faint that is impossible to see with normal lightings. So now just I am putting new point. So it's a very small inclusion. I am using the marker, just putting a click here. So you can increase the circle diameter with plus and minus. So it is an easy task. I just put a marker onto it, click it and right click it once again and finish. That's it. The inclusion is plotted. But so that inclusion is plotted from one side. Now Mbox has a very intelligent system. It will try to guide you from which point it will be seen from the second facet. So just click here. So all motors will move and this same inclusion will be seen from the other angles. So as you can see, this size, the width of this is very wide and it is not correct. This inclusion was actually here. Just make additional contour here and that's it. So from two things, as you can see, the inclusion is caught. And the accuracies are 16 micron, 95% accuracy with 100% it is consistency. Now you will be able to see that there is a small dot which was plotted inside. This is the smallest dot. And if you want to find out how much size it was, So just click on change. It will say 8 by 8 into 7 VVS1 plus. So if it is a high contrast, it will automatically detect as a VVS1 plus. So it's so small, it is impossible to see even in the faintest of a 10x loop or normal helium machine. So for point inclusion, definitely MBOX is the only solution which will be able to plot your IF or VVS inclusions. So this is one of the most critical thing, but it is the easiest thing which you can plot. And now let's plot a bigger inclusion, which can be done on a helium immersion class machine automatically, but let's do it in the MBOX now. So now we take a certain bigger inclusion, not that small point like VVS inclusion. As you can see, we were concerned about the accuracies of placement. So as you can see, this is the kind of consistency is 95%. Sorry, precision is 95 and consistency is 100%. So that means the accuracies at which this VVS point was plotted is so high. It is showing green. That means it is one of the best accuracy which you have plotted. So whatever, suppose if there is an error because of dust, because of your model, because of any other reason, the system will automatically suggest that your inclusion placement was not correct. If it shows yellow or red, it is definitely bad. So now I'm trying to show you the TM, the tone mapping options of MBOX. So these are all different options like gamma, gamma plus, contrast, and likewise. You can definitely play around, but we will suggest this thing for an advanced user. Now let's plot a bigger inclusion. So this is a big inclusion. Maybe it could be I1, SI2, but system will automatically guide us. Don't worry. So we first of all go in the kind of 50x, focus on the inclusion by going inside. So as you can see, now we are going in. First of all, I am clicking on rough, on surface, and then going inside. Trying to see that it is 100, 200, 400, 500, 600, 700, 900, 160, 1130. So I'm going inside the diamond. This is clearly shown by this system. So I want to focus this inclusion. So let's focus, and I think it is quite focused now. So you can, depends on your type of inclusion, or how big is the inclusion, you can zoom it by say 50x or 60x or 160x. So now right click, new 3D inclusion. So this is a big inclusion, we call it new 3D inclusion. Now we plot the entire boundary line. So we go on polygon method. We click, 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 and we finish the entire thing using click, click, and we plot the entire polygon line, making the entire boundary of the inclusion. So that's finished. So from one side, the inclusion is caught. Now once again the same procedure, we go on this button and we ask the system where exactly this inclusion will be seen from the other side. So as he has suggested, so this is the area, yellow area is the area in which your inclusion could be there. So now we know that the inclusion is here. So right click, add contour, and once again the same procedure, add polygon line. So you need to make sure that at least your outer lines, the magenta lines, are covered. So even if it is not seen from here, cover the entire magenta line touching the upper and the lower lines, and then finish. So this 3D inclusion is caught. So once again, let's ask the microscope MBOX that from where it is getting another view or not. So all 90 degrees or 80 degrees, whatever inclusions, he will try to tell you. Once again, we go on asking the computer, where can I see the inclusion from other angle, and he once again show you that okay, take one more shot from here. And now once again we use the same contour method, polylines, and we click the entire contour. And this entire big inclusion will be making a small section, as you can see now. So there was first angle was 0, then there's a 4 degree, and there this is the degree, 85 degree. So minimum two facets from is enough, but exactly if it should be having a certain degrees of say 70 degrees or 80 degrees or 60 degrees. Firstly, we have plotted only 0 at 4 degree. That doesn't give that kind of accuracy and consistency. So now as you can see this inclusion. So this big red inclusion, this M box will automatically signifies the color that this is a bigger inclusion, so it could be I1. So fine. So this is a big inclusion which we have plotted. I think let's ask the computer system what kind of inclusion purity which he has given. I think it is SI1 or I1, and the computer will automatically suggest you the clarity grades. Now let's plot the cracks and the curve cracks. So now once again reduce down the magnification to 7.8x, find out any crack. So once again we are going on a surface, zoom in by 50x, and this is the crack. This is the crack. This is the crack. And it is a straight crack. So it's a kind of a crack or a glaze starting from the surface. Mbox will be keeping automatic saving of these things because a lot of efforts has gone in plotting all inclusions, so it automatically saves all inclusions by itself. So it keeps on saving it. So don't worry about it. It is an automatic procedure so that your work is always saved. What I am trying to do here is trying to center the stone here, cross and here, so that it becomes perpendicular to my surface. So this is one more cracks, but as you can see it is a curve crack. We are going to plot both these cracks. So as you can see this crack is slightly curved. So we call it curve crack, and there is a different algorithm both for flat crack and curve crack. Sometimes we plot curve crack in a different orientations by different fragmenting, but curve cracks are more tricky than the flat cracks. But there is a different algorithm. It is so easy to plot all curve cracks or the flat cracks. So I am trying to focus on the now flat crack. So whenever the circle is green, that means you are seeing exactly perpendicular to your microscope axis. So if it is yellow, it appears it is not perpendicular to microscope. Try to make it green. That is the orientation in which, and you can do it automatically as well. So once again I am doing the same. To ascertain the highest of accuracies, I am going once again on IT cube, putting surface, trying to check whether my surface is the same. If I want to adjust the surface, so I am trying to adjust the surface and I do corrections. So it will adjust automatically. There was no error, so there was 0 micron. There is no problem. Once again I click on rough, go on a surface. As you can see now the flat crack which is seen now easily. So this is the surface from which this crack is originating from, and there is a depth inside. Now we go on new flat crack. First of all, we will put the surface line. So surface line is the line from which the entire crack is originating. That is from the surface. So it's a simple straight line. We finish it. That's it. Now we are going for a deep point. So even if one deep point is good enough, so we now focus on the depth point. So we go on that point and try to go inside the diamond. So we are going inside. As you can see, I am going 124. So now as you can see, it is 269, 293. I am going inside, inside. And now I can see that the depth point, the faintest edge of the crack is seen clear cut with a high contrast. And just right click. So it could be around 177 microns. Add instant deep point. So that's the depth point. Now let us put the entire shape of the crack. So add crack profile. What is the shape of this crack? So we just close the entire crack profile using dot, and the entire polygon line which will make the entire crack. This is a flat crack. Interesting, very accurate, because as you can see, the faintest of the edge depth point is impossible to see without this box. It is impossible. Now let's plot the curve crack. This is the fourth inclusion type we are plotting. I'm trying to get into the curve crack. Zooming it up 50x. As you can see, are you able to see this crack? Yes. So once again, I am just reconfirming the surface line of the stone and surface line of the cube. Just wanted to confirm, but everything is the same. There was no error, so I am not concerned about it. So once again, I am pressing rough, putting a surface, and so we are on the surface of the rough. So if the entire crack is not seen in the entire zoom, so 160x, then it reduces. Now add curve crack. Okay, new curve crack, and now put the line. So the surface line is not flat, it is slightly curved, which I am showing it here. And then right click and finish. So their surface line is a curve. Now once again the same procedure, we are going to have a depth point of the inclusion of this curve crack. We are going on highest zoom now. Now as you can see, distance to rough. So once again we are on the surface. Now we are going inside. As you can see, 192, 240, 264. So now, sometimes we definitely use this TM option because of the watery edges of the crack, which is impossible to see with the normal image processing. So there is an auto contrast method also here. So now as you can see, we have moved inside around 312 microns, and then we put an instant deep point. Okay. That's it. We reduce down. Now once again we give the shape profile, that is the crack profile. We click the entire polygon line and close the entire crack profile. So there are three processes: crack surface line, depth point, and the crack profile. So as you can see, there is a slight curve. As you can see this curve. So we call it twisted crack. Sometimes these kind of twisted cracks are there. You can do it in two different type of cracks, two different flat cracks, but there is a system in which we can do like this. It's a curved crack. This is the only trick in normally the diamond people are allowed to go inside and check whether it is a straight crack or a curved crack. Depends on the crack profile. If you are now conversant with that, there's a point inclusion, 3D inclusion, flat crack and curved crack. That's it. Now sometimes suppose if you want to see that this curve crack is correctly plotted or not. So sometimes the same depth point is seen from the other angles also. So I am trying to see that whether this same point is visible through other edges or not. So as you can see, there is a small magenta line. I am trying to say the add instant depth point, precise point. So even the precision of that will increase from 5 microns to 1 microns or 2 microns. So that kind of accuracies are unachievable only in MBOX. Because you are catching even the depth point from two different angles. So this is your curve crack. And once again we are ascertaining the depth point which is shown as yellow. So we are able to plot 3 inclusions now. No, 4 inclusions. Point inclusions, big inclusions, and crack and flat crack and curve crack. So now we save this project. And we also save the entire photos of the diamond which we have taken, because this can be used later on, because the mortar can move exactly on the photos. So next time if you want to see the same location and we want to show to our seniors that from where these points are plotted, it can be automatically done from the photos also. So in any kind of doubt, if these photos are saved, the machine will automatically move the mortars in such a way that the same photo will be visible and he can see with his own eyes. Now the same all inclusions which we have plotted earlier. Suppose someone wants to find out whether these inclusions are placed correctly or not. So we open the same inclusion.oxt file which we have said earlier. We will load all the photos which we had taken earlier. So we will load all photo from photo sets, load sets, the set 1, the earlier saved photos, and press an OK. So all the photos will come automatically in the same thing. Now we go in the camera. Now we go into 7.8x, we zoom it down. All inclusion which we had plotted earlier, all the 4 inclusion which we had plotted. Now suppose if our senior asks whether these inclusions are correctly placed or not. That point inclusion, 3D inclusion, flat crack or curve crack. Okay, suppose if he is having a doubt that this point inclusion cannot be correct, just click on the photo first. Now this is the photo, but he wants to see the live camera. So just click here, match position to active photo. So all motors will move, it will rotate it, and now you can see this is the live camera. Now from the same thing, he is able to see that this is definitely the inclusion which we are not able to he was not able to ascertain. So for anything, say now we go to curve crack. And this is the depth point, okay, the deepest point. So just go on the same, so match the position. So it will go on the same position from which we had plotted earlier. So this is the current inclusion, as you can see, right? Whether we have got the depth inclusion as correctly or not. So this is the same thing, even for the 3D plots. Suppose this was the photo which was taken, just go on, go to the match position to the same photo, and all motors will move, and the same inclusion will be seen once again. So this is the method of quality check. So basically we humans believe our eyes, and that is very important. Whatever photos we have saved, if we are able to see it live, that's it. Anyone can be convinced. So this is the immersion light, which is the main point. And now I am trying to remove it. Whenever I am switching it off the MBOX, the motor will automatically deaccelerate and it will go and once again go in the back in the same initialized position. So we remove this light whenever we are not using the M-box. So we are always putting it differently. Now there is one more feature of M-box that is known as the cavity plotting. Although helium rough machine can plot cavities, but depth point of the cavities are so tricky sometimes that only M-box can plot such cavities. So let's start the procedure how to plot cavities inside an M-box. So once again, this is the most critical part. Sometimes the cavities are so deep inside and it is so impossible to plot in helium because of the kind of curve kind of cavities. So let's do the same procedure for cavity. So we click on oxygen servo microscope, right click, same procedure, we double click or right click and press enter and the entire process will restart once again. This is the last feature of M-box which is very important because with inclusions the cavity depth accuracies are highly important because sometimes because of planning problems, surface cracks and the cavities are the most vital things and that plays huge role in planning and sometimes the plan gets changed. Sometimes VS1 gets VS2 or SI1 or IF gets deteriorated to VVS and this is the beauty of M-box. So once again you are seeing all the motors are initializing as you can see on the left hand side, all RX, RY, X, Y, Z and your zoom. So all 6 motors will get initialized, wait for some time and the screen will pop up. Now once again I am interested in cavities, so I am now clicking on planning.mmd which means my plan has been done. This is a smart recut plan which we have done. So we have exploited the entire, so we are actually disabling the IG mode here. So we are now cycling this, the front light we are switching it on. Earlier for immersion glass this light was not used, but now we are switching on all the, this is known as flower lights, this is the front lights, so dark field lights, different lighting systems M-box have. These all lights are used for the plotting of inclusions also and cavities also, but with windows. We are now concerned with the cavity, so now we are going for the planning of the diamond and we want to plot the cavity. So now we draw some diamonds. So the best part about helium is that it will give you the touching part. So as you can see that yellow and red, yellow and red, yellow and red and yellow and red. So there are 4 parts which are very critical. Where supposing this pavilion side, this is the cavity which was plotted in helium, but we are not confirmed whether the depth of the cavity is correct or not. And sometimes this is the main factor which reduces down your overall diameter or overall weight of the stone. Sometimes on the girdle, so there are 3 on the girdle, 1 on the pavilion. So very simple. Now we are trying to rotate, the model are matched. We go on 50x. I reduce down the, so this is the cavity. As you can see, of course you are seeing it quite big, as you are seeing in M-box. It's just 50x, but this is the crack. So once again I am going 115x. Now this is the surface line. Suppose 160x. This surface means the model has been built at this surface. Okay. Now let's learn how to plot a cavity. So this is the cavity. Once again, because its cavity is very big, I am going to reduce down the magnification to 20x. So in the cavity, we cannot do the surface correction. So it's very simple. I am trying to focus on the cavity, whole area of the cavity, which is only visible in 20x, making once again our circle green. Once again, going higher with a higher zoom. Surface means the model surface will be coming up. So this is the surface, nearby surface, which is having a polished facet, and this white portion which we are seeing is the cavity. So what we will try to, how you correct the surface in cavity model. Try to find out a surface which is very flat nearby to your cavity and just do the surface correction, if at all, if it is required. So this is the whole area of your cavity. So we have reduced down the zoom, focus on once again on surface. So this is the entire cavity. We are not knowing the exact depth of the cavity, but don't worry, this is how we say view cavity. So we define the entire area in which our cavity is falling. So we are defining the boundary of our cavity. We are finishing it. So this is the surface base. Now we will put some depth point, deep point. We call it depth point. Go on focus. Try to focus it inside. Use highest zoom. Go on surface. Click on the and add instant dip point. So one depth point is add instant dip point. You can use as much as instant depth point. Wherever you are seeing focused area, add instant dip point. Add instant dip point. Only thing is, because we humans can see the focusing and defocusing, we will be adding instant depth point. So you can have multiple instant dip point. Now the system will know that at what depth you are going in, because that's the focused area. So I'm just putting some instant dip point 1, 2, 3, 4 as you can see. Going further, once again perpendicular, going inside, as you can see the laser line, add instant dip point, add instant dip point. So even for your laser lines you can have because laser line are 20 microns deep inside, you can at least, this is impossible for any else other than MBOX to plot such laser line depth, which is just 15-20 microns inside. So now as you can see the yellow dots, these are all your depth point. And this is the original cavity which was plotted on helium with the 2 laser scanning systems, but the yellow dot will be more accurate. And now as you will be able to see, this is the cavity, right? So this was automatically detected and it was made by the your MBOX machine. So as you can see, slightly inside the cavities which were plotted earlier on helium, the MBOX was able to correct it. And now perhaps the same thing is now clearly visible on your diamond with the dark blue line. That means your diamond will be reduced by this much amount. So once again you have to do the planning or the smart ticket planning, because this cavity will have an effect on the overall diameter, overall weight of your future diamond. And that's it. Thank you.